get started. All right, are we all set? Thank you for joining us. My name is Lenny Gutierrez. I'm a technical sales rep for Sun Plastic. We are the manufacturers and distributors of ASA Clean Purge Compound. Our company is part of Asahi Kasei Chemicals, one of the world's leading chemical companies. We're a technology-based company with over 75 years of material science experience. The purpose of today's seminar is to educate you on procedures and being efficient with your purging. General tips is know what your current costs are with your current best purge method. This way you have a benchmark of comparison when you decide to test a purge compound like ASA Clean. It's good to know how much time you're spending, how much material you're going through, and the cost of that time. So that way, when you have a test with a purge compound and you save, let's say, a half hour, you know what that half hour translates into as far as dollars are concerned. We're not kids anymore, but we do need the occasional reminder that we need to follow instructions. Purge compound functions best under the recommendations of the manufacturers, and so we definitely have a very simple procedure that we'd like you to follow so that you can use less of it and maximize the performance. Also, this goes hand in hand with how much resin you will need to use to displace the purge compound. I'd like to talk about shutdown and sealing procedures. This is an opportunity to be preventive, to purge and prevent carbon contamination from happening during your downtimes, during a holiday shutdown, a weekend shutdown, or if it's simply if the machine is down for a shift, because you need to have a mold change. Any kind of stoppage in production would be an opportune time to shut down and seal the machine and prevent any accumulation of carbon deposits from resins that otherwise would not have been able to remove. It's key to keep the screw full of the material so that you keep the oxygen out, and that way you help prevent the carbon contamination. This way you won't have the difficult startups where you're ready to go Monday morning, but all of a sudden your machine is spewing out carbon specks for a couple hours. That's a headache and a waste of your company's dollar. Side note, never seal with glass-filled grades. Similar precautions, just like any precaution from a glass-filled resin supplier. Don't leave the resin in the machine. Too risky of behavior. A good way to know how often you need to purge is to track your reject rates on a graph. That way you know when would be the opportune time to purge and prevent said rejects. This is hand in hand with using the purge efficiently and knowing how to prevent the buildup of contamination in your machine, which eventually, if left unsupervised, will lead to pulling the screw and your maintenance department will be grouchy. Purging compounds we have different grades. Most purge product lines have different grades, so it's good to know and communicate exactly what your needs are, what the resin temperature is, if it's a long temperature transition, or if you're looking to purge through a hot runner. All the information needs to be communicated so that you get the best grade recommended, and then also the best procedure recommended. That's part of purging efficiently. One interesting point of discussion is the cost of regrind. Now everyone says, I purge with regrind, it's free, and it doesn't cost me anything, but couldn't be further from the truth. In fact, regrind costs the company quite a bit. You do need man hours to operate the regrind machine. You need to actually manage and handle the material. It's not a perfect substitute for a product that actually cleans the machine. In fact, regrind, being that it's usually already contaminated, makes contamination even more likely in those particular instances. In injection molding, the procedure is pretty simple. We like to think of it as 2 steps twice. The first step, essentially, is to introduce the purge at a slow screw speed so that the purge fills every flight of the screw and fills it efficiently. with the back pressure at a maximum, specifically for the purpose of keeping the screw all the way forward. You want to keep the screw forward because if you don't, the purges sort of just pull up in front of the screw tip, and it won't have any opportunity to scrub surfaces. It'll just be there without any physical contact to the surfaces you want to clean. So you want to do that and keep the screw forward during this initial step. Once the purge starts to come out of the machine, that's when we want to raise the RPMs, the rotations. That way you get a nice uniform flush through every zone of the barrel and screw. Also, after you initiate the ramp up of RPMs, we like you to stop the screw. That's for a few seconds. It's not a soak time or anything like that. It's just to allow the purge to grab onto, if you will, let the material affinity technology of the purge work, and then start up the RPMs again. So it's kind of, you're using the contrasting RPMs, kind of like a washing machine does. Use that action, and it helps loosen things up and clean up a lot better for the mechanical purge compound. The end of the purge process does not end with the purging of the resin you're looking to purge. It actually ends when you get the purge out of the machine. So it's very important to displace the purge with the very same procedure I just reviewed. Displace it with the same procedure with the following resin, so that you use the least amount of your next resin to push the purge out, and obviously the least amount of time. So overall, you get a savings and efficiency on the material end and the time end. For hot runner tips, well, we're talking about a wealth of information that our technical reps can offer you, because as you know, every mold is unique and has its own personality. But in general, we have a few tips. For example, you want to make sure you purge the screw and barrel first, so you're not introducing contamination from the screw and barrel into the mold. Seems kind of obvious, right? Always check the tolerances of the purge compound that you're going to run through the mold, obviously. For example, we have most of our grades that require a 20,000ths of an inch tolerance. Half a millimeter, I think, is good. So it's good to know that. And again, our glass field warning. Our glass field grade is an excellent cleaner. It works fantastic on the screw and barrel, but just like the warnings with any glass field resin, we don't recommend it to be left in the machine, or we don't recommend it officially through hot runs. Being that it is a mechanical purge, the viscosity of the purge is quite critical to its performance in terms of recommendation at which temperature that we recommend purge at. For example, in many cases, as a standard, we recommend you jack up the temperature 60 to 80 degrees in the manifold to help loosen up some of the stubborn deposits. Again, that would be a discussion with the technical reps, so that we can talk about the balance of the viscosity of the purge versus the making the deposits more easily removed from a temperature like that. Purging through the hot runner, we typically, in general, recommend that you use a closed mold, injecting parts with the purge compound. A lot of our grades are actually very moldable. And usually that's the best way, because you take advantage of the pressures of the system. And so if that's not possible for any number of reasons, then we also have an open mold procedure, which is relatively safe. And that way you can at least observe the behavior of the purge compound coming out of your machine, and then maybe build up the confidence to shoot some parts. That would also apply to high cavitation molds with thin walled parts, where injecting a part of our possibly higher, more viscous grades isn't a realistic expectation. In extrusion, we want to keep in mind the screen and the minimum dive clearances. Obviously, you want to know what you're running through and through what orifice. But in general, extrusion is a lower pressure process. So we got to do what we can to make the purge work for us. We don't have the privilege of back pressure control in most extruders anyway.